Good morning, students. Let us start our class on circles, and this is in continuation of whatever we have discussed in the last class. So today we will start with the length of tangent from a point outside the circle. So what is meant by that? Let's understand it. And before I proceed further, could you please confirm that you are able to hear my voice very clearly and able to view the
Yes,
screen
sir.
properly, dear students? Okay, thank you very much for the confirmation. So, first, dear students, let us understand what is meant by the length of tangent from a point outside the circle. Let's look into this diagram first, and let's take a simple equation of a circle where the center is at the origin, and later we will you know discuss about generic equation of circle. If you look into this circle, dear students, that equation of the circle is x square plus y square equal to r square. That you can make out of it, no? Because the center of the circle is at the origin, and we see the radius of the circle as it is shown as r. So what is the equation of this circle is x square plus y square is equal to r square, correct? And there is a point P which is outside the circle, obviously that is the point P, and having coordinates x1 comma y1. Now from that point P we draw a tangent to the circle. Actually we can draw two tangents, but we draw one tangent, and T be the point where the tangent actually touches the circle. So this is the point T, correct, dear students? Then, if this is the case, then what we say is the length of the tangent is the length of the line segment PT. What is the length of the tangent? Length of the tangent is nothing but the length of the line segment PT. So, length of the tangent, let me write it down. Length of tangent is nothing but the length of the line segment PT. Now, how to find the value of PT is the point of discussion now. It is pretty simple, dear students. Is that we just need to apply the Pythagoras theorem. As we know the equation of the circle, we know what is the radius, that is r. So what we get, OT is equal to r, and we can also find what is OP. OP is equal to square root of as we know the coordinate of the point O and coordinate of the point P. So it is pretty simple. It is x1 minus 0 whole square plus y1 minus 0 whole square, correct? So that is equal to what? Square root of x1 square plus y1 square. That is the value of OP, correct? Now the point is that we just need to construct a triangle. You see that OPT. If you see the triangle OPT, it is a right angle triangle. As it is a right angle triangle, we can apply Pythagoras theorem. So by applying Pythagoras theorem in this right angle triangle, so by applying, just a minute, sorry. By applying Pythagoras theorem, on the triangle OPT, we get what? We get that we need to find PT square. That is our purpose. So PT square is equal to OP square minus OT square. OP square minus OT square. So what is OT square? OP square is equal to x1 square plus y1 square. And what is OT square? That is r square. And this implies PT is equal to square root of x1 square plus y1 square minus r square. That is the length of the tangent to a circle x square plus y square equal to r square. When the tangent is drawn from the point P, x1 comma y1, obviously the point P is outside the circle. Otherwise, you cannot draw the tangent. Now, look into this expression that x1 square plus y1 square minus r square. As if, if you look into this expression, that to memorize it well, as if you make that equation of that, circle as x square plus y square minus r square equal to 0, na? So you just consider this expression that s is equivalent to x square plus y square minus r square. Just consider this expression. And what is the point, dear students, here? Point is x1 comma y1, which is outside the circle. Now, what is the length of the tangent? That is nothing but we found another expression s1 that is equal to x1 square plus y1 square minus r square. Just make a square root of s1. Length of tangent is equal to square root of s1. This is one technique to memorize that how to find the length of tangent. Okay. There is no relation that the point x1, y1 is on the circle. Okay, definitely not. Then you cannot draw the tangent actually at all. Okay, so it is just a technique to memorize that if you make s is equal to x square plus y square minus r square, that is the expression. That is a symbolic representation of the expression as s. And the point is x1 comma y1. Then you find the value of the expression of s when x is replaced by x1 and y is replaced by y1. That means s1 actually x1 square plus y1 square minus r square. Whatever the value you get, make a positive, make a square root of it and you will get the length of tangent. Let us realize this thing by means of a, general equation of a circle. So then it will be much more clear, dear students, okay? Now, let's move our discussion from that circle with a center at origin to the general equation of a circle. Now, consider the general equation of a circle. You know, dear students, what is the general equation of a circle? It is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Correct? So, let's put this thing here. Okay, so as you see, this is the general equation of the circle, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Now, whenever this equation, we know one thing, dear students, that the center is at the point minus g comma minus f. Correct or not? That its center is at the point minus g comma minus f, as you see. And its radius is r. So what we can say about r? We know if this is the equation of the circle, then r should be equal to square root of g square plus f square minus c. Correct? Let me write properly. G square plus f square minus c. G square plus f square minus c. That is the value of r, the radius of the circle. Now here also the point P is outside the circle with coordinate x1, y1. Okay. And we need to find the value of PT, that is the length of tangent. Dear students, the technique what I just learned is that, we express s is something like this: x square plus y square plus 2gx plus 2fy plus c. That is the expression s. And what is the point P is given as x1 comma y1. Then what is the length of tangent? Length of tangent. Let me first write it down, then I'll prove it. Length of tangent should be equal to square root of S1, should be equal to square root of S1, where S1 is nothing but the expression S with in which x is replaced by x1 and y is replaced by y1. That means what? It is x1 square plus y1 square plus 2g into x1 plus 2f into y1 plus c. That's it. Simple. So whenever you get questions that okay, you need to find question related to the finding the length of the tangent, you just apply this and done. Now let's prove it. How we are going to get this one? Length of tangent is equal to square root of x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So here also the same concept, we are going to apply the Pythagoras theorem. As you see, the triangle CPT is an right angle triangle. So by applying Pythagoras theorem, by applying Pythagoras theorem, on the right angle triangle, CPT, we get okay. So what is the length of the tangent? Is PT. So PT square is equal to hypotenuse is CP square minus CT square. So let's find it out. PT square. So this implies PT square is equal to CP square. CP is nothing. We know the coordinate of both the points C and P. So CP square is it's not a big deal to find it out. It is x1 plus g whole square plus y1 plus f whole square minus CT square. CT square is what? That is r square. We know that r is equal to square root of g square plus f square minus c. So r square should be equal to g square plus f square minus c. So now we just need to find the value of this expression, and we'll find it actually. Let's see what we are going to get it. So from here, what we are going to get it is that PT square. Let's do it quickly. x1 square plus 2 into g into x1 plus g square plus y1 square plus 2 into f into y1 plus f square minus g square minus f square plus c. So minus g square plus g square got cancelled, minus f square plus f square got cancelled. So then what we are going to get, dear students? So from here what we get is that PT square is equal to x1 square plus y1 square plus 2g into x1 plus 2f into y1 plus c. So then what is the length of the tangent? So this implies length of the tangent, dear students, is actually square root of, is nothing is equal to PT, and that is nothing but square root of x1 square plus y1 square plus 2g into x1 plus 2 into f into y1 plus c, as if this is equal to square root of s1, where s1 is the value of this expression here, dear students. So this is the way we need to find the the length of the tangent. Correct, dear students? So now let's do one thing. Let's together let us solve one question related to the length of the tangent. And before proceeding this, so let me tell you the method how we can find out the length of the tangent. So the method is that something like this. Let me first show you, dear students. So what is the method we should follow to find the length of the tangent? So I read it out, the statement. First, reduce the equation of the circle to the standard form with the coefficients x square and y square equal to unity and right hand side equal to 0. Okay, then what happens means, for example, if the equation of a circle is given something like this, that 2x square plus 2y square plus 4x minus 6y plus 14 is equal to 0. So we need to reduce it to in a form where both coefficient of x square and y square is unity. So how we can do it? So that is the only way to do it is that dividing both sides by 2. So that means x square plus y square plus 2x minus 3y plus 7 is equal to 0. So whatever you have done, that is the meaning of this statement. What I repeat once more. First, reduce the equation of the circle to the standard form. That equation was not in standard form, and we make it in the standard form by dividing both sides by 2 in the example what I showed. So first reduce the equation of the circle to the standard form with the coefficients of x square and y square equal to unity and right hand side equal to 0. Then substitute the coordinate of the given point in the equation of the circle. The square root of the left hand side thus obtained is the length of the tangent to the given point. That means what? The length of the tangent will be something like this. Length of the tangent, okay, drawn from the point x1 comma y1 to the circle is square root of x1 square plus y1 square plus 2 into x1 minus 3 into y1 plus 7. That is the equation of the, that is the, sorry, not equation, that is the length of the tangent. So this is the method. Now let's solve one problem, related to the length of the tangent, then how we can use this one. So here is the question, and I suggest you also do along with me, and things, so that things will be pretty clear to you at your end. So question is this: find the area of the quadrilateral formed by a pair of tangents from the point 4, 5 to the circle x square plus y square minus 4x minus 2y minus 11 equal to 0 and a pair of radii. Okay, so let's give a first visual representation of this problem, dear students. Okay, so what is the visual representation? So visual representation will be something like this, and then let us discuss. You see the circle is that, as you see the circle is the one that given, that x square plus y square minus 4x minus 2y minus 11 equal to 0. Okay, and this is the point P. As you see, this is the point P having coordinate 4, 5. Okay. Now, from the point P, as it is outside the circle, so we can draw two tangents. One is PA and this PB. Then we need to find the area of the quadrilateral PACB. Okay, why? Because this is the two tangents PAPB and two radii CA and CB. Correct? So we need to find the area of PACB. Okay, so that is equal to what? 2 times area of, let me write properly, dear students, that is equal to 2 times area of the triangle PAC, area of the triangle PAC. Why? Because the area of the quadrilateral PACB is equal to area of the triangle PAC plus area of the triangle PBC. Now, both the triangle are actually congruent if you see here, PAC and PBC. So their area must be same. So hence, we are considering that area of the PBC is equal to area of the PAC. Hence, the area of the quadrilateral PACB is now coming as 2 into area of the triangle PAC. Now, if we focus on the triangle PAC, dear students, what we are going to get? We are going to get that area of that PAC is something like this. 2 times area of PAC. PAC is equal to what? Half into base. Base is what? PA into and the altitude, that is equal to AC. So that implies that is reduced to PA into AC. What is PA? PA is nothing but the length of the tangent drawn from the point P to the circle, given circle. So what is the equation of the circle? Equation of the circle is given, let me use a different color. Equation of the circle is given as x square plus y square minus 4x minus 2y minus 11 is equal to 0. From here, dear students, we can find that coordinate of the center. Okay, coordinate of the center is actually, that is, we can write that here the center is at the point C. Now, so what is that? That become 2, 1. That is the coordinate of the center, 2, 1. Okay, and what is the radius? So if AC is the radius, so what is equal to square root of g square? G square is 4 plus f square is 1. G square plus f square minus c. C is minus 11, so minus c become plus 11. So what we get? 4 plus 1, 5. 5 plus 11 is 16. So square root of 16 is equal to 4. So what we get? AC is equal to 4 units. And PA is equal to, it is very easy to find the value of PA, length of the tangent, dear students. So how we can find the value of PA? Just square root of S1 technique. That means whatever the expression of the circle we get, now x square plus y square minus 4x minus 2y minus 11, there we will apply x equal to 2 and y equal to 1. That means what? 2 square plus 1 square minus 4 into 2 minus 2 into 1 minus 11. Whatever the value we are going to get, that's in, that is the one we are going to find it out. Okay. So what is the value of PA we are going to get? That is equal to, let's see. So this is equal to, this implies, let me write properly, dear students. In the digital board, sometime I face difficulty. That implies PA is equal to square root of okay. Oh, I'm so sorry. There is a small mistake. I have done it here. So here not 2, 1, it is 4, 5. Sorry. Because we need to apply that value, the point P, na 4, 5. So it becomes 4 square plus 5 square minus 4 into 4 minus 2 into 5 minus 11. So 4 square is 16, 5 square is 25, minus 16, minus 10, and minus 11. So what we are going to get, 16 got cancelled. 10 and 11 become 21. 21, 25 minus 21 is 4. So that implies PA is equal to 2. So then what is the value of that area we are going to get, dear students? So PA we apply 2 and AC we got 4. That is equal to 8 square units. AC is equal to 4, that is equal to 8 square units. So this is one example that in which we are able to apply the concept of the tangent. Correct, dear students? Now what we are going to discuss a topic called chord of contact. Let us first understand what is chord of contact. Okay, and then we are going to discuss, we are going to derive its equation and all this stuff. So let's first understand what is chord of contact. Okay, what is chord of contact of a circle? From any external point with respect to a circle, two tangents are drawn to a circle. That we are all aware. Correct or not? Now, if we join these 2 points of contact to the two tangents of the circle, we will get a chord. And that chord is called the chord of contact. So let us understand what is chord of contact. Okay. So let me first give a visual representation and then I'll explain you that by means of a definition. So let's take a circle first, dear students. Okay. So let me draw the circle first. So this is a circle. Now we take a point, outside to the circle. Suppose we take a point P here. Correct. Now from the point P, we can draw 2 tangents that we are aware of. So let me draw the tangents, like this. So this is one tangent. And this is another tangent. Correct, dear students? Now, what we're going to do is that these tangents, touches the circle at 2 points. Okay. So suppose the points are something like this. This is T1 and this is T2. Now T1 and T2 are both on the circle. Correct or not? So now what we are going to do, dear students, is that we are going to join these 2 points T1 and T2. If we join these 2 points T1 and T2, that is what is T1, T2. This T1, T2 is the chord of the circle and that chord has a name that is called chord of contact. So what we can say, dear students, so this, T1, T2, that is known as, I can write it down. So that is known as chord of contact. So as we understood by means of a visual representation, now let's look into the definition of it. So now, if we look into the definition, so it goes something like this, dear students. Let me give the definition here. So let me read it out so that you can make a complete, relevance of whatever I've drawn and explained. So whatever I took it from the study material, I'm just going to read it out. From any external point with respect to a circle, in this case that point is P, 2 tangents are drawn to the circle, which is PT1 and PT2. Now, if we join these 2 points of contact of the 2 tangents of the circle, that is T1 and T2, we get a chord, and that chord, that is T1, T2, is called the chord of contact. Simple. Now, what we are going to discuss? We are going to discuss, the equation of the, chord of contact of a circle. Okay, how to find the equation of the chord of contact of a circle. So Based on the definition, whatever I've given, is that I can let's quickly describe once more that what is meant by this. That though I explained, I'm just showing it once more. Sorry. Here also, let us consider the following diagram. Here, the way I explained, here you see the BC is called the chord of contact of the given circle. Now, the first what we are going to do, dear students, is that equation of chord of contact of a circle. Okay. So, if the equation of a given circle is, if equation of a circle is given, we can find the equation of the chord of contact of this circle in any of the two methods. Okay, so let's look into it. Equation of a chord of contact of a circle. That here, dear students, understanding the concept is very important. First, you understood the definition, and now let us understand the concept that how to obtain the equation of chord of contact of a circle. So, let me read out that statement and explain further. If the equation of the circle is given, this given comes twice, so I just strike it off. If the equation of the circle is given, we can find the equation of the chord of contact of the circle in any of the following two ways. First one, if we know the coordinate of the external point from which the tangents are drawn. And the second one, if we know the coordinate of the middle point of the chord of contact of the circle. So let us discuss these 2 points in detail, dear students. What is the first point? First point is that equation of the chord of contact when external point is given. Okay, so let us first visualize this case and then followed by its explanation. So if we visualize this case, it will be something like this. Let the diagram come, then I can explain. Yeah, it came. You see, let A alpha comma beta be the external point from which two tangents has been drawn to the circle is equal to 0. Okay, so from here AB and AC are the two tangents. Here the chord of contact BC is the equation obtained as t equal to 0, where t is nothing but alpha x plus beta y minus a square, when s is actually x square plus y square minus a square. That means when the circle is actually corresponding circle is having center at origin and having radius r. So this will be the chord of contact, equation of the chord of contact. Second one is that the equation of the chord of contact will be alpha into x plus beta into y plus g into x plus alpha plus f into y plus beta plus c, when AC is actually representing the expression corresponding to the general equation of the circle. So what it says, dear students, in any case, as if that you are finding the equation of that tangent to the circle at the point alpha comma beta, which is meaningless because alpha comma beta is outside. Just to memorize the technique of finding that equation. That is why we use the term t equal to 0. T stands for tangent, but there is no concept of tangent here from the at the point alpha comma beta on the circle, whatever you see in the circle, because the point is outside. But just to memorize, this is the technique. That means if the equation of the circle is x square plus y square minus a square equal to 0, that means this is the corresponding expression. Then we know what is the equation of the tangent to this circle, that is x square plus y square minus a square equal to a square. So if you see x square plus y square equal to a square, if this is the equation of the circle, then what is the equation of the tangent to the circle at the point alpha beta on the circle? That is alpha into x plus beta into y minus a square equal to 0. So we are taking this only this expression, and that is why we give that t equal to 0. Okay, t equal to 0, then means that becomes the equation of the chord of contact. In the similar manner, if we have the equation of the circle in the generic form, that is general equation of straight line, x square plus y square plus 2gx plus 2fy plus c is equal to 0. Now, dear students, for this circle, what is the equation of the tangent to the circle at the point alpha comma beta on the circle? That becomes, we know, alpha into x plus beta into y plus g into x plus alpha plus f into y plus beta plus c is equal to 0, and that becomes the equation of the chord of contact. So these are the 2 points we have discussed here, means when the circle having the center at origin and when the circle is generally given as a general equation of a general form. So equation of the chord of contact when the external point is given. Now, dear students, what we are going to discuss is that equation of the chord of contact when the midpoint of the chord is given. When the midpoint of the chord is given. So what is this? So let me first visualize this problem and then followed by its derivation of the equation of the chord of contact. Not exactly derivation, means what is the equation of that chord of contact. Because in this context, derivation is not that very important. You can do it by your own using the fundamental concepts. But what is very important is that to memorize what is the equation of the chord of contact. So here in the previous case, what was alpha beta? Alpha beta was the external point from where the tangents are drawn. But here we are going to find the equation of the chord of contact when midpoint of the chord is given. So here BC is the chord of contact. No? So its midpoint, let's assume P. That means PB is equal to PC, where the coordinate of the point P is alpha comma beta. Correct? So then, then the equation of that chord of contact BC is obtained as T equal to S dash. Okay, so just to memorize it properly, what is T? T is as if alpha x plus beta y minus a square, and S dash is equal to alpha square plus beta square minus a square. When S is x square plus y square minus a square, that means as if when the equation of the circle is something like this, that x square plus y square is equal to a square. That means equation of a circle having center at the origin and having radius a units. This is the equation of the circle. Then if for this circle, if we know the midpoint of the chord of contact as alpha comma beta, we know the mid of the coordinate of the midpoint of the chord of contact, that is BC, what you see is alpha comma beta, then how we can find it out? T equal to S dash. What is T? T is nothing but alpha into x plus beta into y minus a square is equal to S dash. S dash means what? It is alpha square plus beta square minus a square. Just to memorize it effectively. Okay, so this is the equation of the chord of contact. Now, if the equation of the circle is given in the generic form, that means what? X square plus y square plus 2gx plus 2fy plus c is equal to 0. Then, dear students, what we are going to find? And we know the coordinate of the midpoint of that chord of contact as alpha comma beta. Here also the same technique. What is the technique? Technique is that, T equal to S dash. What is T? T is as if the equation of the tangent to the given circle at the point alpha comma beta on the circle. As if what it will be? It is actually become that alpha into x, if you recall, plus beta into y plus g into x plus alpha plus f into y plus beta plus c, okay, equal to s dash. S dash is equal to what? In that expression of x square plus y square plus 2gx plus 2fy plus c, we are replacing x by alpha and y by beta. So that becomes alpha square plus beta square plus 2g into alpha plus 2f into beta plus c. That is the equation of the chord of contact in terms of the midpoint. I hope it is very well understood, dear students. Any difficulty, please do let me know. So, with this, I would like to, conclude the class for today. In the next class, dear students, we are going to discuss something called a radial axis. And you will find it very encouraging discussion in the next class as well. And with this, I would like to conclude the class unless you have any specific question for me. Thank you very much.